Selamat pagi, ni hao, hello. Today, I would like to talk to you about web components and an experimental JavaScript API called the Accessibility Object Model, or AOM. When we load some HTML into the browser, several things happen more or less at the same time. The HTML gets translated into the DOM tree. It also gets translated into the accessibility tree. And finally, it gets translated into the user interface, the part that we can see and we can interact with. So if we take a button element, our HTML is very, very simple. Just open and close the button element with some text content in the middle. Our DOM looks exactly the same. We see that element as a node in the DOM tree and the text leaf in the middle. When we look at the accessibility tree, we get more information about this node. And the node in the accessibility tree for this button element says that it has a role of button, that its accessible name is play, that's the text inside the button element, and that its state is focusable. So if you use a keyboard and not a mouse or a trackpad, you can use the tab key to focus on the button and interact with it. Our UI then presents a button on the screen that we can click or interact with a keyboard or touchpad. And with a bit of styling, it looks hopefully reasonably presentable. So if we were to try and create a button element using a web component, there are a couple of ways we could do this. We could use a customized custom element. This takes the HTML button element and extends it. So it means that when we set up our web component, our constructor is really simple. We just call super because that's good practice in web components. And we don't need to do anything else apart from give our custom element a name. In this case, custom-button. If you're not familiar with web components and custom elements, they must always have a dash in their name. And this is just to help the browser separate a native HTML element from the HTML spec from one that we've created as developers through the custom elements API. Our connected callback is also really simple. We don't need to do very much at all. We just need to add some click functionality to make our button work, and that's pretty much all there is to it. Our HTML, however, looks a little bit ugly. We use the button element as we would in standard HTML, but we add the is attribute to it. So we say button is custom button. So our HTML has already grown another attribute, which is not too terrible, but it's not as clean in code terms as we might like it to be. Our DOM looks pretty much exactly the same. Nothing much changes in that translation. And our accessibility tree also looks pretty much the same. It still says it's a thing with a role of button. The text is still its accessible name, and it's still focusable. So effectively, what we've done is just recreate the button element as a custom element. And we can see this work pretty much like you'd expect a button to work. Only this time, we'll hear a screen reader announce the button too.
Play button.
And the screen reader picks up that information from the accessibility tree. It recognizes the accessible name, play, and it recognizes that it's a button and tells the user that information. There's a problem, though. Apart from the fact that the HTML looks a little bit less clean than we want it to be, customized custom elements are not particularly well supported. They're not supported in WebKit. Apple is pretty firmly opposed to introducing support for customized custom elements. So we might have to turn our attention to autonomous custom elements. Now, an autonomous custom element doesn't extend an existing HTML element, so we can't inherit all the good behavior from, say, button that we just did with the customized element. Instead, we have to start pretty much from scratch, and that means we've got to do all the work that the browser does for us normally for ourselves. So in our constructor, we need to set things up a little bit differently. You'll notice that the definition is slightly different. This time, I'm going to create a toggle button as well. You may have noticed from the video we just played that that button looked different when it was pressed, but the screen reader didn't pick up on that information. So we're going to set about creating that toggle button. So the definition has changed to be a toggle dash button this time. And if we look at the connected callback, there's an awful lot more going on inside it. We need to set the role, just using set attribute. So that's the bit that fills in the accessibility role. We need to set tab index to 0. That's the bit that will make our custom element focusable with the keyboard. And we add in an ARIA attribute, ARIA pressed, and we set it initially to false. This is the attribute that will tell screen readers and inform the accessibility tree that this is a different kind of button. It's one that can be turned on or off, and we'll see how that develops. We hook a function into the click and keyboard event handlers, and we're just going to switch the status of the ARIA pressed attribute over. So when someone uses the keyboard or the mouse to interact with the button, we'll flip the value to true while it's pressed and flip it back again to false when it's not pressed. And this will change the accessibility state information in the accessibility tree. So our HTML looks a lot more simple. We just open and close our toggle-button element, and we still put the text on the inside. Our DOM, however, starts to look a little bit messy. We see all the attributes we've just set inside the custom element, the tab index, the role, the ARIA pressed. They actually leak out from the custom element into the DOM. So unfortunately here, things start to get a bit more messy looking. Our accessibility tree has also changed a little bit. The type of the button, the role of the button is now toggle button. In some browsers and some accessibility APIs, it's known as a push button. So this is just a different type of button. Everything else is pretty much the same, but the state now also has a recognition of the fact that this button can be pressed or not pressed. So there is more name, state, and role information available in the accessibility tree in the browser. When a screen reader or another assistive technology queries that information from the browser, the experience for the user changes quite dramatically.
Play toggle button not pressed. Pressed. Not pressed.
So we now have a custom element that is a toggle button. It has all the accessibility characteristics that we need to inform something like a screen reader that it's a toggle button. And the user now gets to understand when that button is pressed and when it's not. So the experience is a lot better for someone who can't see the visual state of the button changing. Here's where we come to that experimental JavaScript API I mentioned. The AOM is still relatively new. It's being developed in the Web Platform Incubator Community Group, the YCG, at the W3C. And it's being worked on by people from Apple, Mozilla, and Google. And it's a JavaScript API that will let us get involved in that relationship that I mentioned in the very first slide, that until now has only happened within the browser. So up till now, the accessibility tree has only ever been created by the browser, and the only thing that has access to that accessibility tree other than the browser are assistive technologies like screen readers. For the first time now as developers through the AOM JavaScript API, we're about to get access to that tree ourselves. And that opens up a lot of different possibilities and also a few challenges and things that we're going to need to be aware of. Phase 1 is going to introduce ARIA reflection. It means we're going to be able to set different roles and attributes and have them reflected back. So it keeps things much simpler and lets us use more familiar JavaScript syntax. So for reflecting the attributes, there are two interface mix-ins that have actually been added not only to the AOM specification, but they will also be added to 1.2 of the ARIA specification. ARIA is Accessible Rich Internet Applications. And these two interface mix-ins will let us reflect back roles and other ARIA attributes. So if we rewrite our connected callback for the toggle button, we can see the change in syntax. Instead of having to use set attribute, we can use element.role equals button to set the role of the element. We can use element.tabindex equals 0 and element.aria pressed equals false. Notice, though, that the way tab index and aria pressed are written has changed. There's now a capital I on the index of tab index, where there wouldn't normally be, and the dash has gone from the aria dashed pressed attribute, and instead it too uses camel case. So all of these aria attributes have a slightly different way of being written, but they achieve pretty much the same thing. We set all those properties and characteristics exactly as we did in the earlier example. We can also, or we will be able to, set element references. Now this is where we get into the part that is still so experimental, it doesn't actually exist in the browsers yet, not even behind the flag. But what we'll be able to do is where we have an element, an attribute like aria described by, which up till now you can use to point to another piece of content on the page, using its ID value as the reference point, and it will associate that piece of text with the first element. So Typical example is you focus on a form field with a screen reader. You'll hear the label of the form field announced, the type of the form field announced, and then you could use ARIA describe by to associate an extra hint to help someone fill out that information. And the screen reader would automatically read that out too. Putting ID references on things is often quite heavyweight. You can have hundreds, sometimes thousands in a heavy application of ID references on a page. But what will happen in the future is that we'll be able to use just plain JavaScript element references in our code instead of having to use ID references. So for example, we'll be able to use ARIA described by elements to feed it one or more reference points for the information we want to hook up in the user interface. But as I say, this is experimental yet. We can't play around with this feature. If you're curious, there is a series, a harness of web platform tests available for phase 1A. At the moment, if you take a look at it in Chrome or the new Edge Chromium beta, you'll find that about 65 out of the 95 tests are currently passing. So that's all the attribute and role reflections, but none of the element reflections. Safari is doing really well with about 79. Interestingly, WebKit Safari has taken it out from behind the flag, so this works actually at the production level. In Chrome, it's still behind the AOM accessibility flag. Firefox hasn't yet introduced any support behind the flag or otherwise, but I'm pretty sure it will catch up soon. So hitting those tests in your browser is a pretty good way to keep up to date with how much of phase 1 is currently available to play with. Phase 1B introduces custom element semantics. Now, the idea behind this phase is that we can start to clean up some of that DOM leakage that we saw with our toggle button example. We don't want all the tab index, the role, the ARIA pressed, the other attributes to leak out into the DOM when we create a custom element. We want to keep the accessibility encapsulated. So this is the part of the spec that will let us do that in two different ways, ultimately. We'll be able to set accessibility characteristics at the time the custom element is created, and ones that can be adapted and changed in the element internals. So, for example, we could change our code slightly so that our element definitions options include things like setting the role and the tab index, because we want those to be established in the custom element the moment it's created, exactly as though we were using a standard HTML button element. We can then do per instance semantics using an internals variable. We can attach the internals in the constructor for the custom element, and that lets us set things that will change through the course of the custom element's lifetime. So ARIA pressed will change in response to user interactions. So we set that here instead of as an immutable characteristic in the element definition options. But as I say, unfortunately at the moment, we still can't play with this just yet. Phase 2 is all about user interactions and events. We're all really used to events like click, key down, key press, a whole bunch of others. But when you introduce an assistive technology like a screen reader into the equation, things get a little bit more complicated. So they are going to change the way that events are synthesized and also introduce some new events. The reason for the synthesis is to protect the privacy of assistive technology users. So if they were just to create some assistive technology events, it would be very, very easy to detect not only that the user was using a particular assistive technology, but what type of assistive technology they were using. And that, of course, would make it very easy to determine that the person was blind because they're using a screen reader, had mobility impairments because they're using speech recognition. And so obviously it's important that we protect that user privacy. So what happens is when someone using a screen reader carries out an action, it will synthesize a click event, for example. So particularly on touch devices, if you tap a device with a screen reader running, it's a double tap gesture, not a single tap that you'll be used to, but that will synthesize a click event. And similarly, other events are cloaked, if you like, using these synthesized events. They're also going to introduce some new events, particularly increment and decrement, scroll up, scroll down, and dismiss. And this very much plays into touchscreen devices. At the moment, it's pretty much impossible to create a custom slider using all the accessibility characteristics that are available, and to have it usable with a screen reader on a touch device. The reason is that when you have a screen reader running on your touch screen, flick up and flick down, the gestures you'd probably use to adjust the value of a slider are already used for screen reader specific commands. So there's no way that those commands can be separated out into using a slider. They're always protected, they're always ring-fenced for the screen reader. So if you go to something like the ARIA Authoring Practices Guide and pick up the blueprint design pattern for a slider there, implement it perfectly, but try to use it on a touchscreen device with a screen reader running, it won't work. The slider can't be adjusted in the way that you'd expect. So these are being put into practice. These new events will come along to help us get around that problem. Phase 3 will let us introduce virtual accessibility nodes into the tree. This is where we really start to get our hands on that browser-only functionality. We'll be able to add entirely new nodes into the accessibility tree. Up until this point, there is always a corresponding DOM node for an accessibility node, but we can change that. This is the bit where it starts to feel really scary. What we don't want to happen is for developers to start creating entirely secondary accessibility trees just for screen reader users that bear no resemblance to the DOM. Good practice is always going to be to try and keep those two things synchronized with each other. But one really clear use case is doing something with the canvas element. When we draw something to the screen using Canvas, it's all done in JavaScript. So there are no HTML elements. There's no accessibility semantics that are available to the accessibility tree, and so to screen readers. So one use of being able to add virtual nodes to the accessibility tree is that we can attach a shadow root to the Canvas element. We can then start adding a virtual branch of the accessibility tree in there to provide fallback content specifically for people who can't see the JavaScript rendered content inside the Canvas element. But this is a long way off now, and there's a lot of obstacles to getting to this point, but it really does have some interesting possibilities. Phase 4, lastly, is probably the most complicated of all the phases. It's going to give us access to all the computed accessibility properties in the accessibility tree, both for the accessibility nodes that are associated with DOM nodes, but also for the entire accessibility tree. We'll be able to walk through the accessibility tree in the same way that we can walk the DOM now. So again, it's going to open up a lot of possibilities for functionality and capability. But I think they're keeping this one till the last phase because it is the one that's going to take the most discussion, the most thinking about. So looking at those things, this is how we can think about building accessibility into our custom elements, recognizing that if we use autonomous custom elements, we need to add in the accessibility characteristics for ourselves, and that the AOM in time is going to give us a lot more flexibility to do that. But we can also use custom elements, in fact the whole web component stack, to solve accessibility problems as well. Oh, sorry. So we can create a speak content element, for example. I use a screen reader, and one thing I quite often do is if I want to look at the news, I will go and set my screen reader reading a news item on the website, and then I'll go off and make myself a cup of tea while I'm still listening to it, because I don't need to look at the screen. My screen reader on my headset is portable. I can just walk around the house, put the kettle on, make the tea, and still listen to the news story. And I've often thought this would be a really useful thing for everybody to be able to do. Being tied to your chair, to your computer, your laptop is not always the ideal experience. So perhaps we can use custom elements to create a widget that will let us have a button on screen that will read a designated piece of content out loud. And it turns out it's reasonably easy to achieve. We can use the HTML template element to set up the actual element. We'll chuck some styling in there just to make the button and the div look good. We will also use some slots to manage things. So in the template, we've got a button element that contains a slot element, and this will let us pull through content from the light DOM, from the developer code. And we'll also set up a div that's also going to be a slot for the content that we want to be spoken out loud. In our connected callback, we will do all sorts of things. We will grab the control, the thing we'll hit to make it speak. We'll grab the element that contains the content, and then from there, we'll grab the content that we want to be spoken out loud. In our function, we will set up the web speech API to make it talk. We'll create a speech synthesis object, and we'll attach to that the text that we want spoken out loud that we've grabbed from the light DOM. And then lastly, we need to set a timeout, because what we want to do is, lastly, make the button look like it's been pressed for as long as the content's being spoken, and then we want to return it to its default state when it's finished. We're using the ARIA pressed attribute again to make sure that that happens in the accessibility state as well as the visual state. Our reset state then just checks after 500 milliseconds, and it checks to see if the speech utterance is still talking. If it is still talking, it resets the timer for another 500. If it isn't, then it returns the state of the button back to non-pressed. We'll do one last bit of under-the-hood magic, and we're going to attach the visual state of the button to the attribute selector using ARIA pressed. So as the value of ARIA pressed is changed, the visual style of the button changes accordingly, and it just makes the whole thing sync up a lot more easily under the hood. And what we get at the end of it is a very simple piece of text on page, a button that we can hit, and hopefully everything all works for everybody.
1 tequila, 2 tequila, 3 tequila, floor.
And so custom elements, hopefully this has given you a brief insight into, can be used not only, as I said, to solve accessibility problems, but if we get them right, add in all the accessibility properties that we need to. They give us a really powerful way to create new and useful features on the web. I need to really thank a couple of people, Scott O'Hara and Patrick Lauker and Dan Hopkins, who all gave me a tremendous amount of help while I was putting this together. There's a URL on screen from Pat, which leads to a way to implement a slider that will work in accessibility terms on touchscreen devices. You basically use a native slider element. You hook it up to the custom visuals that you want and make sure you keep it all in sync. But if you're curious about an interim solution until the AOM arrives, that's a really good one to check. But otherwise, I recommend that you follow all of these people. They're all damn good developers in their own right and pretty damn good people too. And lastly, thank you very much to all of you.